Hello dear student, welcome to Q Physics Academy. So this is our next lectures, part 2. Basically this is part 2. Okay, part 2 of Jest 2023 PIQ solution series. Okay, so in this in today's video I will discuss question 7 to question 17 in details. Each concept I will discuss in details. Okay, so I hope I hope the 2024 all PIQ it's very helpful for your preparations. Also the part 1 for just 2023 it is also very useful for your preparations. So I hope this video also is very helpful for your preparations. Okay, so as usual, I am Methun Patra. I am a PhD scholar at ACPS Niger. I am actually working in exoplanetary atmospheric characterizations with JWST. Okay, so next starts our video with question number 7. Okay, question number 7. So what is the questions? Consider a free particle. Okay, consider a free particle in one dimension described by the wave functions. Here given a wave functions at psi t equals to 0, the probability current density corresponding to psi xt. So here given actually the wave functions given psi xt equals to 0, but they find out the probability current density for psi xt. We already know probability density. Probability density is independent of time. Okay, probability density is independent of time. So probability current density is exactly same for psi xt equals to 0 and psi xt, because probability density is independent of times, right? We already know. So we are now trying to calculate here the probability density for this psi xt equals to 0 for the given wave functions. So here not to first of all find out the wave function psi of xt and then calculate the probability current density using the probability current density formula. You just follow the given wave functions and just put just calculate all the mathematical terms in probability current density expressions, and you can definitely get the probability current density for psi of xt0, xt equals to 0 and psi of xt. Both have the same form. Okay, because probability density is independent of time, right? So we are here the solutions. And solutions. So we know the probability current density for probability current density, the probability current density jxt or jxt equals to 0, it's same. Okay, that is equals to h cut upon 2mi psi star del psi upon del x minus psi del psi star upon del x. Okay, so this is equation number 1. Now we calculate for the given wave functions. Here the given wave functions psi x t equals to 0, that is equals to okay a exponential ipx upon h cut plus b exponential minus ipx upon h cut. Okay, so taking its complex conjugate, this is equation number 2. Taking its complex conjugate, taking its complex conjugate. Okay, this is equals to a star exponential minus I px upon h cut plus p star exponential plus I px upon h cut. This is equation number 3. So first of all, we compute del psi upon del x. Okay, first of all we compute from equation 2, okay, from equation 2 we calculate first of all del psi upon del x. Okay, so what is the value of del psi upon del x? So it is equals to ip upon h cut a to the power ipx upon h cut minus ip upon h cut b a to the power minus ip upon h cut. Similarly del psi star upon del x, that is equals to minus ip upon h cut a star a to the power minus ipx upon h cut plus ip upon h cut b star a to the power ipx upon h cut. So these are the two values. Now we calculate the from equation 1, from equations 1, okay, we get jx comma 0, that is equals to h cut upon 2mi. Jx comma 0 or jxt is have the same value, don't worry about that. Okay, okay, first of all first of all we calculate this value. It is very easy. Okay, from these expressions, psi star del psi upon del x. Okay, psi star del psi upon del x, that is very important. So that is equals to a star e to the power minus I px upon h cut plus b star e to the power plus I px upon h cut into ip upon h cut a e to the power ipx upon h cut plus, not plus, minus ip upon h cut b e to the power minus ipx upon h cut. Okay, so after simplifying these expressions, we get ip upon h cut a star a minus ip upon h cut a star b e to the power minus 2i px upon h cut plus ip upon h cut b star e to the power, not minus, this is plus, e to the power minus 2i px upon h cut plus ip upon h cut b into b star. Okay, okay, this is very good. Okay, in a similar way, we calculate psi del psi star upon del x. Okay, del psi star upon del x. In the similar manner, psi del psi star upon del x, that is equals to okay, IP upon each cut, IP upon each cut, okay, psi a to the power I px upon each cut plus p e to the power I px upon each cut into del psi star upon del x minus ip on each cut a star e to the power ipx on each cut plus ip upon each cut p star e to the power ipx upon each cut. Just multiply these two terms, that is equals to minus ip upon each cut a star plus ip upon each cut a p star e to the power plus 2i px upon each cut, okay, minus ip upon each cut b a star e to the power minus 2 ipx upon each cut, okay, plus ip upon each cut p into p star, okay. So this is equation number 4, this is equation number 5. Now just subtract these two equations. Now equations 4 minus equations 5, we get psi star del psi upon del x minus psi del psi star upon del x, that is equals to ip upon each cut a star a minus ip upon each cut a star b e to the power plus I 2 ipx upon each cut, okay, plus ip upon each cut p a star e to the power minus 2 ipx each cut plus ip upon each cut p b star minus plus ip upon each cut a star minus ip upon each cut a b star e to the power 2 ipx upon each cut minus a plus ip upon each cut p star e to the power minus 2 ipx each cut minus ip upon each cut b star, okay. So now just rearrange the each functions in proper way and we get finally a very good result. So okay, so from these expressions we get ip upon each cut a star a minus b star b, okay. So that is equals to ip upon each cut mod a square mod b square, okay. So finally jx comma 0 that is equals to jx comma t that is equals to h cut upon 2mi that is actually 2. Okay, that is actually 2, don't worry, 2 h cut upon 2mi into 2ip upon h cut mod a square to mod b square. So you have a 2 cancel each other, h cut cancel each other, I cancel each others. So finally we get p upon m mod a square minus mod b square. So this is the final expressions of probability current density. This is the final expressions for probability current density. Okay, so for what this is, so आपको याद रखना है probability current density jx of t or jx comma 0 have the same value because probability density is independent of time. Okay, टाइम के ऊपर डिपेंड नहीं करता है एक्चुअली. सो टाइम फैक्टर टाइम, तो यहाँ पे जस्ट probability current density corresponding to the wave function psi of xt is a, so don't worry about that. For calculate the density, okay, probability current density or any kind of density using the wave functions, because the probability density is independent of time. Okay, so don't worry about that. So option A is the correct answer. No, option not option A, option B is the correct answer from the corresponding questions. Option B is the correct answer. Okay, so this is the question number 7. Very long questions, it is very lengthy questions. We just calculate each and every step in proper way. Okay, next we go to the question number 8. Okay, just go through this question. What is the questions actually? It is very good questions. Okay, this is very good questions and very important questions for Jest examinations. Very important questions for Jest examinations. Consider all possible Boolean logic gates. Consider all possible Boolean logic gates with 2 inputs and 1 output. Okay, with 2 inputs and 1 output. All are the logic gate. Okay, so how many such gate can be construct? How many such gate can be construct? So you know, here a Boolean logic gates having 2 inputs, okay, A and B, and 1 output, right? This is the Boolean logic gates. Consider all possible Boolean logic gates with 2 input 1 output. How many such gate can be constructed? So can you know number of input combinations? First of all, we know number of input combinations. See the solutions. Number of input combinations, that is equals to 2 to the power 2. That is the number of input combinations. So these combinations are actually A comma B. Okay, so this is actually 0 comma 0, 0 comma 1, 1 comma 0, 1 comma 1. These all are the combinations, input combinations. So now next calculate the possible output. Possible output. Next we calculate possible output. Okay, so each of the 4 input combinations can independently map either 0 or 1, either 0 or 1. Here I will write statements. Please understand the concept. Each of the 4 input combinations. Okay, each of the 4 input combinations can independently be mapped to either 0 or 1, right? So thus the number of way to define the output is h 2 to the power 4, that is equals to 16. Okay, the combinations. So this means that there are 16 possible Boolean functions or gate with 2 inputs and 1 output. So write a statement. This means that there are 16 possible Boolean functions or gates with 2 inputs and 1 output. Okay, so this is the final answer is 16. So option A is the correct answer. So consider all possible Boolean logic gates with 2 inputs, 1 output. How many such gate can be constructed? Okay, 16 type of gates we are constructed for this using this Boolean logic gate. Okay, next question number 8. Question number 9. What is the question? If linearly polarized light is sent through two polarizer, okay, it's sent through two polarizer, first at 45 degree to the original axis, okay, 45 degree to the original axis of polarizations, and second at 90 degree to the original axis of polarizations. Okay, so what fractions of the original intensity passes through the last polarizer? Okay, so first of all we understand the diagram. So we have a two polarizer. Okay, we have a two polarizer. This is the original axis of polarizations. Original axis of polarizations, and the polarizer is at 45 degree. Polarizers are at 45 degree, and also the second polarizer at 90 degree, the original axis of polarizations. Okay, 90 degree to the original axis of polarizer. This is the axis. This is the axis of first polarizer, and this angle is 45 degree, and here placed another polarizer, and this is the angle is 90 degree. So from the axis of first polarizer it is an angle 45 degree. Okay, and we are trying to calculate the I0 out, right? I0 out. So this is the actual configurations. So for to calculate the actual intensity of light after passing through this polarizer, we use the Maley's law. Okay, Maley's law. So Maley's law, what is Maley's law? Can you know what is Maley's law? What is the statement of Maley's law? State that when light of intensity I0 passes through a polarizer, okay, passes through a polarizer at an angle theta to its polarization axis, it is important. Polarization axis, then the transmitted intensity I out is equals to I0 cos square theta. So for first case, okay, for first polarizer, okay, the first polarizer, what is the case for first polarizer? The first polarizer is oriented at 45 degree to the axis, right? The polarizer is oriented at 45 degree to the axis. Okay, so transmitted intensity after the first polarizer, transmitted intensity after the first polarizer is I1 equals to I0 cos square 45 degree, that is equals to I0 root 2 whole square, that is equals to I0 by 2. Okay, for the second polarizer, okay, The second polarizer is oriented 90 degree related to the original polarization axis. Okay, we just write down the points. Oriented 90 degree relative to the original polarization axis. Okay, original polarization axis. What is the meaning of that? This means that the angle between, this means that angle between the angle between the light after the first polarizer and the second polarizer each also 45 degree. This means the angle between the light after the first polarizer and the second polarizer is also 45 degree. So again apply Mal's law. So the intensity I2 that is equals to I out that is equals to I1 cos square 45 degree that is equals to I0 by 2 that is equals to half, so I0 by 2. So please remember this concept. This concept is very important. Okay, this concept is very important. Please remember this concept in proper way. Okay. Okay, so final answer is actually 1 by 4. So what fraction? So they ask what fractions actually. I out for I0 that is equals to 1 by 4. This is the fractions of light is actually transmitted. This is the fractions actually. This is the fractions of light is actually transmitted to this after this second polarizer. Okay, so this type of questions in Jest examination they are asked in many times, so just be careful about the process. Okay, next question is question number 10. What is the questions? A rocket, okay, a rocket is moving in free space. A rocket is moving in free space with speed c by 2, with speed c by 2 after a fuel tank is gently detached. Okay, after a fuel tank is gently detached and the rocket is found to be moving with a speed c by 4 with respect to the detached fuel tank. Okay, with respect to the detached fuel tank. So what is the final speed of the rocket in the original frame of reference? So what is the final speed of rocket in the original frame of reference? It's a nice question, right? It's a nice questions. It is a nice questions they asked in your examinations. So first of all, to calculate the final speed of the rocket in the original frame of reference, we use the velocity addition theorem. Yeah, we already know about that. Okay, so calculate the final speed of the rocket. relativistic velocity addition, so we use the relativistic velocity addition formula. Relativistic velocity addition formula, that is equals to v prime equals to v minus u 1 minus bu upon c square, where v is the initial speed of the rocket initial speed of the rocket before detaching the fuel tank. Okay, u, what is u? U is the speed of the rocket, speed of rocket relative to the detached fuel tank. V prime is the final speed of the rocket. Final speed of the rocket. Okay, so these are the basic idea about that. Rocket in the original frame. Okay, in the original frame. This is an idea. This is an idea about that. Just here the plus sign. Okay, now one by one we substitute the value, substitute the given value here. 1h c by 2, another h c by 4, 1 plus c square by 8 into c square, that is equals to 4, 2c plus c, 1 plus 1 by 8, that is equals to 3c by 4, 9 by 8, 3c by 4, 8 by 9, so 2c by 3. So exact answer is 2c by 3. Okay, so exact answer is 2c by 3. Okay, the exact answer is 2c by 3. So from these questions, option B is the correct answer. These were nice questions. Next we go to question number 11. This is another nice question, very important. This is another nice question, also very important questions. It is also very important questions. Okay, two identical magnetic dipole of length L, which are free to rotate and are kept fixed at a distance d, and d is very greater than L. Okay, if their minimum energy configurations, they will orientate themselves at what conditions. What is the orientations? At what orientations they give the minimum energy? Minimum energy means minimum interactions energy. Okay, minimum interaction energy. So we are already know the interactions, dipole, magnetic dipole interactions energy. Okay, magnetic dipole interactions energy U equals to mu 0 upon 4 pi d cube. D is the distance between two dipole, that is equals to m1 vector dot m2 vector minus 3 into m1 vector r cap into m2 vector r cap. Okay, this is the formula for dipole interactions energy. M1 M2 are the magnetic dipole and r cap is the unit vector along the line joining the two dipole. Okay, we just write here M1 and M2 are magnetic dipole moments. Okay, and r cap is the unit vectors along the line joining the two dipole. Okay, so these dipoles will orientate themselves at what orientations they gives you minimum energy. Okay, so here U is minimum depends on the angle between M1 M2 and their alignment actually. So U is minimum, it depends on the angle between M1 M2 and their alignment with r cap So first of all we check options here, one by one we check the options. This is the option checking. If we check option A, anti-parallel to each other and perpendicular to the line joining. Anti-parallels means M1 and M2 have the negative value. Anti-parallels, option is anti-parallels, it means M1 M2 cos 180 degree, that is equals to minus M1 M2, that is equals to negative value, and also perpendicular to the line joining, right? Perpendicular it means and M1 vector r cap M2 vector r cap, it is equals to 0. So as here this this is for anti-parallel and this is for perpendicular. Okay, for perpendicular this result will be 0 and for anti-parallel this is negative. So it means U is here negative or U is negative, it seems minimum. Okay, right, so this energy, this minima is the energy. Okay, use minimum. Okay, so these conditions is satisfied. Okay, if we go to for options B, just checking parallel to each others, it means m1 m2 is positive, okay, positive, and aligned to the line joining them. It means it's parallel, okay, it means it's parallel, it means it's parallel. It means m1 r cap dot m2 r cap, it's not equals to 0. So it is not minimize the energy, okay, it's increase the potential energy, it is increase the potential energy, it is increase the potential interaction energy or potential energy. So this is not a good options. If we go for option C, right, anti-parallel to each others and aligned to the line joining, okay, anti-parallels means negative, okay, okay, but aligned to the line joining, again not equals to 0. So one negative, another negative, so it, okay, so what is the case? It's a parallel, it's a parallel, it means not equals to 0 but positive, it is also positive, right, it is also positive, it is negative, it is positive, again increase the energy, again increase the energy, it does not minimize the energy, okay. Option D, parallel to each others and perpendicular, okay, parallels means positive, yeah, parallels means positive, okay, and perpendiculars means vanish. So it's a positive, it's a positive, so it's a value greater than it's a value of positive value, but for options A it's a negative value, right, it's a negative value. So options A is the right options here, option A is the right answer, okay, this is the right answer, this is the right answer from the option checking. So this is not valid, this is also not valid, okay, so it's not valid, only options A is the correct answer from the above expressions, from the above statements in the given, yeah, okay. So only anti-parallel to each other and perpendicular to the line joining them, so they have to minimize the energy configurations, okay, minimize the energy configurations, okay. Okay, question number 12. What is the question? Nice questions. The force experienced by mass confined to move along the x-axis. The force experienced by mass confined to move along the x-axis of the form f of x equals to k1x minus k2 x to the power n, in the form x is the displacement of the mass from x0 to from x equals to 0, okay, k1 k2 are the positive constant, n is a positive integer. For small displacement the motions of the mass remain symmetric, okay, for small displacement the motions of the mass remain symmetric. What is the meaning of that? Its meaning of that, if I consider this is the x equals to 0, okay, the displacement the displacement due to the positive x directions and due to in the negative x directions, if same, it means the amplitude is same. If the amplitude is same, then we call the motion of the mass remains symmetric. The motions of the mass, motion is actually symmetric. Motion is symmetric. It means amplitude about the origin at x equals to 0, it's same. Okay, and where it is same, when the applied force on this mass along the positive x directions and force along the negative x directions are same. Okay, when the force acting on the mass at x equals to 0, at x equals to 0 along the positive x directions and along the negative x directions is same, then the motions of the mass remain symmetric. Okay, so for small displacement, the motions of the mass remain symmetric. About x equals to 0 if f of minus x equals to f of x. This is the exact conditions. Okay, this is the exact conditions. Okay, so now we use these conditions. So f of minus x is equals to plus k1x minus k2 minus 1 whole to the power n x to the power n, that is equals to minus k1x minus k2 x to the power n. Okay. And these two forces are opposite direction. Okay. I have the wrong conditions. This have a minus con. This is the exact conditions is the force directions are opposite. So this is equals to plus. This is equals to plus. Okay. So these two values, these two terms are cancel each others, right? These two terms are cancel each others. So that is equals to minus 1 into minus 1 whole to the power n k2 x to the power n, that is equals to k2 x to the power n. So these two terms again cancel each other. So finally we get minus 1 whole to the power n plus 1 equals to 1. So at what value of n we get the result to satisfy these conditions. This is the exact conditions for symmetric. So if n is odd and positive, then we get the value. If n is even and positive, then we get negative value, right? So if n is odd and positive, then we get this type of motions actually for the given force. N is an odd and positive integer. Option B is the correct answer. Odd and positive integer. For odd and positive integer, for get the for small displacement, the motion of the mass remains symmetric about x equals to 0. Okay. Next go to the question number 14. Next we go to question number 40. Nice question. Just a question they are asked many times. Okay. So calculate the contour integral, right? Calculate the contour integral. Here given a integral. Here the clockwise contour. Okay, that is very important. That is clockwise contour. See, encircling the point at z equals to a in the complex plane. Okay, what is the value of these integrations? So we are trying to calculate this contour integrations. cos square z minus z square upon z minus a whole cube into dz. We are trying to calculate this. Okay, so first of all we are identify the singularity, right? So z minus a whole cube equals to 0, so z equals to a is a third order pole, is a third order pole. Okay, is in third order pole, right? Is in third order pole, right? So from that type of case, we'll calculate the residue at z equals to a. At z equals to a equals to, okay, 1 by okay, residue at z equals to a, that is equals to n minus 1 for factorial limit z tends to a d n minus 1 upon dz n minus 1 z minus a whole to the power n f of z. Okay, so we just substitute the value one by one, where n equals to 3, so 3 minus 1 factorial limit z tends to a d2 upon dz square z minus a whole cube f of z is equals to cos square z minus z square upon z minus a whole cube. Okay, so these two terms are cancel each other, so finally we get 1 by 2 factorial limit z tends to a d2 upon dz square cos square z minus z square. So okay, that is equals to limit, that is equals to 1 by 2 limit z tends to a d by dz 2 cos z minus sin z minus 2z. Okay, these two as cancel each other, so finally we get limit z tends to a d by dz minus, okay, not 2 cancel each other, half sin 2z minus 2z. Yeah, that's fine, that is fine. That is equals to half limit z tends to a minus cos 2z into 2 minus 2, minus minus cancel each other, minus 2 taken out, so minus 2 upon 2 limit z tends to a cos 2z plus 1, so minus minus cancel the minus, so limit after applying this, my limit cos 2a plus 1. This is the final expressions of residue, so now final value of this integrations using Cauchy integral theorem. So integrations value, that is equals to 1 by c cos square z minus z square z minus a whole cube into dz, that is equals to minus 2 pi I. Why it is minus? Because clockwise directions, the encircling here the clockwise contour C is encircling the point Z equals to A. That's why, okay, that is equals to minus cos 2A plus 1, so minus minus plus 2 pi I cos 2A plus 1. Okay, yeah, this is the answer. Option C is the correct answer. From these questions, option C is the correct answer. No, sorry. Option C, not C, option B. Option B is the correct answer from these questions. Okay, these type questions are very easy questions. Okay, you know this type of formula, how to apply this type of formula. You already know about that, right? So each questions are very important. You calculate each questions in details. Each questions are very important. That's why I give you the full detailed solutions of each questions. I not follow here that kind of step, that kind of process. I use the step jump process, etc. But some questions are important to deal with some conceptual thinking. Okay, some questions are important to deal like that. That's why we deal that type of questions using this. But most of the questions I deal here, in details explanations. I follow here the detailed explanations methodology, right? So my prescription is very clear. I follow that kind of prescriptions. I follow that kind of layout where the details explanation is here. Okay, yeah. What is the next question? Oh, this is very easy questions. Question number 15. What is the second complement of these representations? What is the second complement of these representations? Yeah, it's very easy. How can we do the second complements? Inverting all weights and adding 1. Step 1. Inverting all the weights. What do you get? We get all the bits 1 to 0, 0 to S. So inverting one bit. So what is it get? So we get here 1 1 0 1 0 1 1 0. After inverting first complement, that is called first complement, is equals to 0 0 1 0 1 0 0 1. This is the first complement. And step 2, adding 1 to the inverted result, right? Adding 1 to the inverted result. So okay, 0 0 1 0 1 0 0 1, adding 1 with this inverted results. So we get 0 1 0 1 0 1 0 0. So this is the final expression 0 0 1 0 1 0 1 0. So this is the second complement of this bit. Okay, this number, Boolean number. So okay, so this is very easy questions, right? This is easy question. Just many times बस बीच बीच में इस टाइप का easy question लोग पूछ देता है, ठीक है? जेस्ट लोग भी ऐसा मज़ेदार काम करते रहते हैं हर बार। बट तुम देखो इतने सारे क्वेश्चन हम लोग सॉल्व किया, राइट, इतने सारे क्वेश्चन हम लोग सॉल्व किया, उसमें से सिर्फ इस 15 वाला क्वेश्चन को छोड़ के सारे क्वेश्चन से वेरी लेंदी टाइप क्वेश्चंस. So when you perform and when you give your just examinations, be careful. Here no questions, here no anyone questions have you got something right, like without derivations you got the results, okay, without using the pen and paper you got the result in just examination. It is impossible. So please keep in mind that each questions have some derivations, each questions have some calculations. So calculations efficiency is very important for just examinations. It is clear. I suggest you keep in mind that the information, that kind of informations, that just examination is for the checking for efficiency of calculations, efficiency of concept, okay. बट इन बीच बीच भी आपको क्या मिलेगा, बीच बीच में आपको थोड़ा बहुत इस तरह का इजी क्वेश्चन भी मिलते हैं, देते हैं वो लोग. हम लोग 2014 वाला पेपर भी देखा, इसमें भी इस तरह का इजी क्वेश्चन होता है, वो सबके लिए है. तो आपके पास 25 क्वेश्चन होगा, 25 में से आप मान लीजिए आपके पास 20 क्वेश्चन ऐसा होगा जिसको कैलकुलेशन करना पड़ेगा, 5 क्वेश्चन ऐसा होगा थोड़ा बहुत आपको जस्ट इस तरह का जिंदगी टाइप का क्वेश्चन मिलेगा, यू नो, राइट. क्वेश्चन इज़ वेरी इजी, क्वेश्चन इज़ वेरी फ्लॉपी टाइप क्वेश्चन, इस टाइप का क्वेश्चन आपको मिलेगा. सो आपको 5 क्वेश्चन इस तरह का मिल ही जाएगा. बट आपको जो बचा हुआ रिमेनिंग 20 क्वेश्चन है, उस 20 क्वेश्चन में से आपको स्कोर करना है, तो आपको डिटेल्स टाइम लगा के क्वेश्चन सॉल्व करना होगा. एक एक क्वेश्चन को टू द पॉइंट कैलकुलेशंस करना है आपको, तभी जाकर आपको आंसर मिलेगा. ऐसा नहीं है आपको 2-3 लाइन कैलकुलेशंस करने के बाद आंसर मिल जाएगा, ऐसा क्वेश्चन तो नहीं है. Okay, so be careful. Next questions, question number 16. Yeah, again another long calculation type questions. Okay, again another long calculation type questions. Okay, so what is the questions? A quantum particle moving in one dimension. Okay, it's fine, it's one dimension. Is in the state having the wave functions, okay, having the wave functions sine hyperbolic x exponential minus ax to the power 4 plus bx ipx, okay, h cut a b comma p are positive numbers. What is the expectations value of momentum? Okay, what is the expectations value of momentum? We know the momentum operator minus I h cut ddx. This is the momentum operator, okay, you already know the momentum operator. So we calculate the expectations value of momentum operators. So the expectations value of momentum operators is equals to minus infinity to plus infinity. So psi star x minus I h cut del del x psi x dx. This is the exact formula of calculating the momentum operator. So here the wave functions, given wave function is here. So first of all we calculate the d psi upon dx. First of all we calculate this d psi upon dx. What is the value of that? Okay, so derivative this wave function, this part, this is equation 2, this is equation 2. So we derive the equation 2. Okay, so you get cos hyperbolic lambda x lambda exponential minus x to the power 4 plus px plus ipx upon h cut plus sine hyperbolic lambda x, okay, exponential minus x to the power 4 plus px plus ipx upon h cut into minus 4a x cube plus b plus ip upon h cut. This is the first result. Okay. Okay, let us take common sine hyperbolic lambda x exponential minus x to the power 4 plus px plus ipx upon h cut. So finally we get lambda cos hyperbolic lambda x upon sine hyperbolic lambda x, okay, plus b minus 4ax cube plus ip upon h cut. So this part is nothing but the wave functions, given wave function. So that is equals to psi of x lambda okay, lambda cos hyperbolic lambda x upon sine hyperbolic lambda x plus b minus 4a x cube plus ip upon h cut. Okay, now we multiplied with these functions is I h cut minus I h cut del psi upon del x, okay, minus I h cut del psi upon del x, that is equals to psi of x minus I h cut lambda cos hyperbolic lambda x sine hyperbolic lambda x plus h cut is cancel each other, h cut cancel each other, so okay, minus ib, okay, minus plus I 4a x cube minus plus only p. Okay, this is the result for h cut del psi by del x. Next, this substitute the value in this equation 1, substitute the value of this in equation 1, but we know the probability density, so we have calculate here the momentum expectation value momentum operator, okay, expectation value momentum operators, okay, yeah, we just check here the psi x, that is symmetric actually. Okay, just calculate the term, that is equals to minus infinity to plus infinity psi star x into psi x lambda cos hyperbolic lambda x upon sine hyperbolic lambda x minus ib plus I x cube plus p into dx. Yeah, that's fine. Yeah, so that is equals to minus infinity to plus infinity psi x d square into lambda cos hyperbolic lambda x sine hyperbolic lambda x minus ib minus 4a x cube p into dx, right? This is the result. Okay, now we know the probability density, that is psi mod square is symmetric in x, obviously in x terms, so that are odd in x. Odd in x in means such that x's cube terms. This is the odd term. We integrate 2 with odd term. It will be given 0 value. Okay, just clear about that. Lambda minus infinity to plus infinity cos hyperbolic lambda x sin hyperbolic lambda x psi mod x square dx. Okay, minus ib minus infinity to plus infinity dx plus p minus infinity to plus infinity dx. This is the case. Plus I 4a minus infinity to plus infinity so cube dx. You just focus on this last term. Okay, psi of x is symmetric term. This is symmetric and that is antisymmetric. So this integration must be 0, right? This integration must be 0. This is symmetric, it is antisymmetric. This term is must be 0. And the hyperbolic function term averaged out. This is the average value, right? Average value. This is the average value of this. This is the average value. But in your questions, must you check the options, right? Must you check the answer. Just to check the answer, they find out the expectations value in terms of momentum, in terms of B, in terms of P, or in the H cut. This is the average value, right? It's have some average value. This term has some average value of cos lambda x by sin lambda x, and this is equals to 1. So finally we get like something average value minus IB plus P. So we get the expectations value momentum operator. It's have some value. It's like that. Okay. So from these options, we definitely say the expectations value momentum it's equal to P from these options. So not H cut by lambda, not B, because imaginary terms incorporate with the B terms, and momentum is here the positive terms. So only options B is the correct answer from the given questions. So this is just a option checking type questions, right? Here some gap, here some have value, okay, but in the options no options their incorporate the average value with momentum operator P, right? And also this in one options they given the B terms, but this is the real terms, but in our case P is imaginary. Okay, so this part is already neglected. Only P is valid here, but P is positive. There is two options, option negative or positive. There is a positive value, so expectation momentum is exactly P, not exactly P, but it's equivalent to P. Okay, so please careful about that. So this type of questions we use the approximation method. So this type of question they ask many times in your exam, right? So don't confuse about that. You calculate up to that and you can no options match with the questions. Just use your sense. Okay, just use your sense for this type of questions. They ask the questions for your checking your presence of mind. How can you deal this type of questions, right? This kind of examination is important, right? Okay, next is question number 17. Yeah, question number 17. Okay, in the last don't worry, in next video we deal question number 17 to question number 25 in the next video. Okay, so today's video is there up to question number 16 because the video timing is very high. लगभग ये 120 मिनट का 1 hour 20 मिनट का वीडियोस हो गया, राइट? सो नेक्स्ट वीडियो में हम लोग क्वेश्चन नंबर 17 से लेके 25 क्वेश्चन तक हम लोग पूरा डिस्कशन करेंगे, पूरा डिटेल्स डिस्कशन करेंगे, ठीक है? हम लोग यहाँ पे 10 से लेके 11 क्वेश्चन डिस्कस किया आराम से इस वीडियो में. ओके, 11 क्वेश्चन हम लोग डिस्कस किया इन डिटेल्स. सो प्लीज़ एक एक वीडियो का सॉल्यूशंस आप अच्छे से देखिए, अच्छे से नोट डाउन करिए, क्योंकि एक एक क्वेश्चंस आपके लिए बहुत इंपॉर्टेंट होने वाला है. और जो कॉन्सेप्ट हम लोग डील कर रहे हैं उस कॉन्सेप्ट को अच्छे से समझने की कोशिश करिए. और जो स्टूडेंट का कुछ थ्योरी वगैरह में प्रॉब्लम्स है, अगर एक भी प्रॉब्लम्स हो रहा है एक पर्टिकुलर थ्योरी में, तो वो कमेंट में मुझे मेंशंस करिए. मैं उसका वीडियो आपको जो थ्योरी होता है, एग्जैक्ट थ्योरी नहीं, जो इक्विवेलेंट थ्योरी होता है, जो थ्योरी चाहिए एक्चुअली एग्ज़ाम पॉइंट ऑफ व्यू से, वो मैं ज़रूर उसके लिए एक वीडियो अपलोड करूँगा मैं, ठीक है? तो कुछ स्टूडेंट के साथ फेडरेशन थ्योरी रिलेटेड कुछ प्रॉब्लम्स हो रहा है लोग, तो उसका भी वीडियो मैं अपलोड करूँगा, ठीक है? ओके, सो आज के लिए यहाँ तक है. तो आप लोग इस वीडियो को अच्छे से एंजॉय करिए, और अगर इस वीडियो का कुछ बेनिफिट मिला आप कमेंट करिए, लाइक करिए, सब्सक्राइब करिए चैनल को. जो वीडियोज़ है वो दोस्त को शेयर करते चलिए, क्योंकि ये वाला वीडियो बहुत ही यूनिक वीडियो फॉर्म में है, यूनिक डिस्क्रिप्शन से. अब देखिए, अब ये जो सारे सोल्यूशन है यूनिक फॉर्म में आ रहा है, ठीक है? डिटेल्स डिस्क्रिप्शन से आ रहा है. ओके, राइट? सो प्लीज़ लाइक, सब्सक्राइब एंड शेयर दिस वीडियो इन योर फ्रेंड. ओके, थैंक यू फॉर वॉचिंग दिस वीडियो.